All right, welcome back. I'm going to go ahead and dive right into our very first lecture. So this first lecture is light and image, which is particularly important for photographers because you need to understand how light interacts with the world. Light right here, right, can happen differently in the world versus our eyes versus through the lens. And all of that has to do with nature, physics, and biology as well. So while we aren't in a biology or psychology class, we do need to talk about that a little bit. And I am a little bit nerdy when it comes to the science of color, light and color specifically. So this is one of my favorite lectures, and I think a very important thing for all photographers to know about just a little bit. Okay, so this is in fact lecture one, light and image. In order to talk about light and image, we also need to talk about what is a camera? What are these fancy toys that we are utilizing to capture an image? And also, what is a photo? How are these things captured? What is the science behind what's actually going on with these fancy little devices that we carry with us in our pockets every day? Okay, so number one, how do we see images? We see images via a number of complex mechanisms, either mechanical or biomechanisms, meaning of a body, which record image and color. And different devices, different mechanisms will do this in slightly different ways, but there are major similarities in both the eye and the camera. So I like to equate the two of those together because by understanding the eye, you will understand the camera better. And by understanding the camera, you'll also understand your own eyes a little bit better. Ooh, okay, I said I was a nerd. Here it comes. So the human eye has evolved, right? So we've all evolved via adaptation over many, many, many years. And the way that this is theorized to have happened, this is a very simplified theory of how our eyes came to be. But number one, what happened is that uh, there are organisms down in the sea. And if you go on this journey with me, imagine you're down in the ocean and the organisms who can evolve and adapt are the ones who have a heads up, right? So imagine if you're swimming around in the ocean and there is suddenly an organism, a fish, that can see little patches of shadow. So this happens via photoreceptive cells. So there are cells on the skin of this creature that can somehow sense where there's light and there's shadow. So imagine if you're a fish, close your eyes, you're swimming in the ocean, and all of a sudden you see a shadow pass over yourself. What might that mean? Ooh, if I were a fish, I would think, oh, alarm bells, that might mean something's happening around me. I don't know if that is maybe a predator coming, or maybe that's some other big mass that is traveling over me. Either of those things seem potentially dangerous. So if I were a fish that could see light and shadow, I might think, oh, okay, so there's a big shadow over there. I'm going to swim in the opposite direction and I'm going to swim as quickly as I can, right? So that fish now has a heads up. So that they're going to be selected naturally, natural selection, right? And those are going to continue to live and thrive versus a fish or an organism who can't, right? That's just like a superpower. That's a benefit to those fish. So then if you go along this ocean journey with me, now imagine that this fish not only knows kind of where these shadows are coming from where the shadows are heading, but they can actually kind of hone into, okay, so not only is there a big mass over in this direction, it's actually coming from right there. That is because these photoreceptive cells have actually formed into a divot. So now these cells can say, okay, if you imagine a semicircle and the cells right in the center are saying, hey, there's a shadow, that means there's something directly across, versus if it were maybe these cells over here, it would be something coming from that opposite direction, right? So you can kind of get an idea. Do I need to swim up? Do I need to swim down? Do I need to swim northwest? Where do I need to go to get away from these shadows that are potential predators? Right? How do I not get eaten? All right, so now imagine that those divots of photoreceptive cells actually form kind of a coating over them. They create a globe, and within that globe, fluid starts to fill. Okay, so this is a really rudimentary eyeball, right? And with that, not only comes the perception of light and shadow, but also some imaging. So now, if I'm a fish, I can say, okay, well, that's a boat and it's no problem. Or that's a shark and that's a huge problem. Or hey, that's food and that's something I really like. Okay, so now you can decide where things are coming from very specifically, and also to a certain extent what they are, which is very valuable. So continue on. Imagine those fish are living and thriving and having all sorts of babies. Now you're going to get a globe of an eyeball plus some protective coating. So now all of a sudden you have the superpower of seeing where light and shadow is coming from. You're seeing these images, and you can protect this very, very sensitive piece of your biological mechanism, right? Because eyeballs are very, very sensitive. If you've taken a self-defense class, you know, go for the eyeballs because they're very, very fragile. So if you have a coating over that, i.e. a cornea and some eyelids, well, then you're all the better for it, right? So that's an additional protection of your superpower. So all of that is to say, eyes have come very slowly, starting out very, very rudimentary, with just a perception of light and shadow, into directional, into images, into the eyeballs that we know and love today. Okay, so now here's a no longer rudimentary biomechanism. So eyeballs are very complex. I won't be testing you on this. You don't necessarily need to memorize it, but it is helpful to know kind of the major points of the eye, right? And also, as we're thinking about major points of the eye, I also like to think about those in terms of my camera. Right? Okay, so let's talk briefly about this. So up at the top here, I spoke briefly about the cornea. So the cornea is a protective cover. What is a protective cover in our camera? It's a lens cap, right? So essentially a lens cap is our eyelid. It can turn our image on and off. Light sensitive, covered, uncovered. So cornea, essentially equal to a lens cap. And then we'll kind of dive into the lens, which is our sophisticated surface. So this is actually a convex shape so that it can funnel. Remember the directional movement of these images. A lens is always convex. Okay, so we have the lens, that's pretty equitable, and a camera and an eyeball, same name, comes from the same idea. Then we have the body. So in our eyeballs, we have the vitreous body, which is just filled of a fluid, right? Our camera also has a camera body, so we refer to this as the camera body. Okay, and then we get to some exciting things. So at the back of our eyeball, that's where our photoreceptive cells lie. And what does photoreceptive cell mean? It just means a cell, just like a skin cell, a brain cell, any type of cell that you have in your body. But these are special because they're photoreceptive, meaning they receive photographic information, mainly light and color. Okay, so our photographic cells actually live in the back of our eyeball, and they coat that entire backside of our eyeball so that when we receive this information, via our cornea and our lens and our vitreous body. It then hits these photoreceptive cells, and those can collect that information. Similarly, our cameras also have something in the back of them. So in this particular camera, this is an older camera, the body that would actually receive all of that information and change based on light and shadow is the film. Now, in a modern camera, the DSLRs also have this backing that has receptors, and those come in terms of essentially what eventually becomes pixels. So the more sensitive your camera can read equals the higher quality image, i.e. the more pixels it has. Okay, so there are bodies and mechanisms within your DSLR that is also recording light sensitive information, i.e. light, shadow, and color. So same thing that happens from a film camera also happens in a digital camera, just a little bit differently. Okay, so the bodies that are sensitive and can record that information from the eye to film to a digital camera is all just a little bit different, but they all work very similarly. And then we have this optic nerve. So that is where this information is recorded and transported. So that also can be, if it's a film camera, you take that film out, you go develop it, and you essentially project that image onto a separate paper that then records it. That's how darkroom photography works. Or if we have a DSLR, the device that records and sends information is our SD card, right? So that's essentially our optic nerve, the optic nerve of our camera. Okay, so all of that I find very fascinating because it helps us understand how our eyes record color and how the camera records color, and also light becoming image. So the combination of light and color is image in both our eyes and the camera. All right, moving forward here, the electromagnetic spectrum, other than just fun words, what is that? So that's the idea that there are light waves bouncing around us all the time. So not even light waves, there are waves bouncing around us all the time. And those can be in the form of radio waves, microwaves, that's how you heat your food. And then in the middle of that, there is a certain wavelength. So what does that mean? It means these waves are traveling around us all the time, and they can be different sizes. So depending on the size, it kind of depends on how we perceive them and thus what their function can be. There's a small section of that, which is the electromagnetic spectrum, and that is the visible light spectrum. So this rainbow is the visible light spectrum. It's a very small portion of the larger electromagnetic spectrum that we can see and perceive with our eyes. And Newton actually discovered that all light is made up of all of these different wavelengths that when you use a prism and separate them, they turn into the rainbow. So white light and sunlight contains all the colors. When you separate them, Newton used a prism to do that, you can get the entire rainbow. So all of our colors actually exist within this visible spectrum, i.e. the rainbow. Okay, so that is to say, all of these waves are bouncing all around the world, and we can perceive them based on how they bounce off an object and into our eyeball, okay? And the size of the wave dictates what color it is, and then our photoreceptor has different rods and cones, and those help further perceive what our brain says, oh, this is blue, this is red, etc. So there are light waves bouncing around us all the time. Our eyes help us consume that information and then translate it into something that we know and understand. To translate this back to image, there's an exercise. This is going to be an extra credit exercise. If anyone actually does this in their bedroom and sends me a photo, I will give you 5 points extra credit. So this is the Camera Obscura challenge, and this is just to decipher how light waves are functioning in the world and how a camera actually works. So you can turn your bedroom or your bathroom or any room that has a single light source into a camera. How do you do that? You find a black box. So it can be your bathroom with a single window, it can be your bedroom with a single window. You're going to black out that entire room. So you're going to cover all of the vents, you're going to cover the crevices in the doorways, you're going to cover the entire window, but you'll cut out one hole. And you're going to have to kind of decide for yourself how large that hole needs to be. It's going to be anywhere from a dime to a quarter size. When you cut that out of the hole against your window, all of the light will come in from the scene that is from outside that window, and it will come in through this hole, and there will be an image. It will be like an upside down movie playing, projected onto the other side of your wall. And that happens because these light waves are bouncing directly across, going through a straight line and coming all the way down here. So this little light particle is on its journey directly there. And this little light particle is on its journey directly there. So basically, we're just limiting the amount of light rays that can come into your room. Therefore, we're letting in only enough to project a single 2D plane image on the other side. Okay, and that's why it's upside down, because these light waves travel in a straight path. Okay? So try it. I have had a handful of students try it, and every time it has phenomenal results. It's so fun to see. It can be hard to take a picture of because you're in such a dark room. So the pictures, you might have to do a long exposure or get a really sensitive camera. iPhones work pretty good for that. But go ahead and try it. The results are so much fun. I highly, highly recommend, and that will give you a lot of insider knowledge on how that actually functions, how these light waves can actually be recorded in these tiny boxes that we carry with our hands, captured on film or a digital screen, what have you. You can actually turn your space into that camera. Okay, so next up we're going to talk about photography itself. So what is photography? It comes from the Greek word writing with light. And I really love that translation because in photography, we are artists. If we want the world captured exactly how it is, it's impossible. Photography is always a way to funnel the natural world through our biomechanisms, through our eyes, through our brains, and through our creative processes. So photography is not simply a recording of the world as it is. It really is an artistic endeavor. You can manipulate photographs quite a bit just simply by what you choose to include, what you choose to exclude, how you choose to frame it, how you choose to focus, what you're focusing on, what the subject matter is, how the light falls on it, what time of day are you photographing this. All of these are questions that the artist, the photographer, gets to decide, and that then creates an image. That's going to be a static image, right? It's a representation of the world, but it's not an exact replica. So we are painting with light. We are writers of light. We get our inspiration from the natural world, from these things right in front of us, but we get to be artists. We get to decide how we paint with that light, how we decipher and articulate that light. Okay, so writing with light is what we do. Photography can happen either on paper with chemicals, that's how old school film and darkroom photography would work, or we can do it with computer screens and pixels. That does not mean that we are any less artists because we are painting with light on a screen. It's equally as fun, it's equally as malleable. We can move it and change it and make all sorts of decisions about it. Therefore, we can create different products for our viewers, for our audience. Okay, and here's a couple of examples So this is Ansel Adams, very famous Southwestern photographer, really active in the mid 1900s. So this particular one is 1944. Ansel Adams is very famous for his landscapes and also his sensitivity to light and shadow. So he definitely was a painter of light, right? He is very famous for depicting sun rays and clouds, and you can see this as if it were a brush. So throughout photo history, there's always been this conversation of painters versus photographers, and they always fight with each other. Who's better? Who's a better artist? I will argue that you can paint with light as a photographer. It doesn't have to be so removed from that process. So you can kind of imagine these light rays as if they were painted across the sky very beautifully, and the sensitivity, this full tonal range, we'll talk about tonal range later, but all of these lights and darks within this image, it's just so sumptuous. You feel like this image has depth, it has a sensitivity to it. So this is an artistic photograph. This isn't just Ansel saying, oh, I saw this rock and I thought it was cool. No, this is considering the whole image. This is considering a tone. When you see this image, you have a feeling about it, right? It might be peaceful or heavenly, or if you're looking at the rocks themselves, it might be jagged and scary. It might represent some sort of journey. You can read a lot through this photo, and that's the difference between photo as a utilitarian tool. You know, I need to record this rock. Maybe I'm a geologist, versus a fine art photo. This scene is my painting. This scene is my gift to my viewer, essentially. Okay, let's move on to your camera specifically. So I will mandate that you all have your DSLR next week, but for this week you might not have it, and that is okay. But I really want to dive into the parts of the camera for those of you who have it, and for those of you who are getting your cameras very soon, you'll know some things about it. Okay, so I'm going to use, yes, this camera. Okay, so a couple of important things to know. If you have never ever held a camera before, that's okay. I'm going to show you some things about it. So number one, you do have a strap. It's always a good practice to throw that strap over your head if you want to do it this way, or if you want to, you know, be cute and fancy, you can do it side style. This is really just a safety precaution in case you drop it, especially if you're out and about in the world, if you're shooting on location. It's going to be very, very helpful that you have a little device, because again, these are sensitive little mechanical parts. You really want to keep good care of it. Okay, lens cap. So when the lens cap is off, it actually is reading light through the lens. It can drain your battery, even if it's off. So go ahead and pop that on. It also protects your lens. If you get a scratch on your lens, you're going to get a scratch in every single photo you take with that camera. Okay, so really take care of your lens. It will help to have a little microfiber lens cloth, like for your glasses, for your computer screen. Little microfiber cloth that's not going to leave lint. You also want to make sure that your lens is not dusty or linty. But this device here is your lens cap. Lens caps work pretty differently, but it should just be a little pinching motion. You can take it off. Okay, and then let's see here. So every camera, every DSLR, the lens can remove itself. Usually there's some sort of button. It might be here, it might be here. You'll push that button, and you'll do this very, very carefully. Once you do this, this is like taking that protective screen off all of your electronic devices. Once you do that, you're opening the doors for things to happen. So press that, and then you can turn the lens very, very gently. Once it stops rotating, you can go ahead and lift it straight off. That is how you remove your lens from your camera body. Now this information in here, that is the most sensitive part of your camera. Do not leave it naked. Do not leave it open for long, okay? But just so you know, that's how that can happen. If you need to clean your lens, or if you need to look at different things, that is how you do that. To put it back on, you'll match up. Usually there are little dots or squares that you'll line up. Usually they're red. So I have, let's see, I actually have two little, I'm matching up my white rectangle to my white rectangle. You might do that with dots. It might be dots or squares, but you'll match up the shapes. Different camera brands have different shapes, but you'll match them up, lay it down, and then snap it back into place. Once you hear that snap, you know you're safe again. Okay? You'll have an on-off toggle somewhere. It might be there, or sometimes they can be up here. Okay? So either way, on or off, you'll always want to charge it. So again, the battery can be in different places. You'll always want your camera off when you take out the battery or the SD card. Mine here, the battery is at the bottom. There's a little trigger. I can pop open that battery. You'll take that battery open to pop it into the charger. So if your camera is not working when you first get it, it could be because it just doesn't have a charge. Okay, when you turn it on, you'll probably have a screen of some kind. I do really like this camera because it has the old school like camcorder screen that you can pop open and closed. But you'll have a couple of different menu options. So you can look, this is more of a video recording screen there that I can look at things live. Or you can do static images. You can review your thumbnails via that screen. Each camera works a little bit differently, and then we'll go into more of these buttons a little bit later, but I have an aperture right there. Sometimes the aperture is a toggle, so you'll click aperture at the top with your pointer finger and then toggle it back and forth up here. All of these different settings, you can rotate, pick different settings for the purposes of this class. You will always want yours in manual, M for manual. We will be doing everything in manual. Do you have to keep doing that for the course of your photographic career? No, but for the purposes of really understanding how to use your camera and how to be good at it, we will be using manual only. That is why it is very, very difficult to use a cell phone in this class, because you don't have all the manual controls with a cell phone. There's a lot of auto functions. Auto functions are the devil in this class. We do not like them. Why is that? Because we want to be able to manipulate our photographs as much as possible. That's part of the artistic process. That's part of painting with light, is being able to make all of the different choices to make an artistic image. Okay, so that's probably all you need to know about your camera at this point. Our first project will be, you can use your DSLR if you have it already, or it will be iPhone friendly, with my knowledge that some people might not have their DSLRs quite yet. Okay, if you do get a DSLR and you're not already familiar with it, download the manual, have the manual handy. I am not the god of photography. I don't know all of the problems of all of the brands, of all of the models, of all of the cameras in the world. I do know quite a bit, so I can probably help you troubleshoot, but the best things that you can have in your back pocket are your manual, Google, and YouTube. Because I guarantee someone's had this problem. Someone's had the exact same problem as you at some point in history. And so for troubleshooting your particular model, it will be very, very helpful that you just get in the habit of kind of finding and troubleshooting this information. Archiving a lot of helpful information so that when you get into a pickle, you know where to go to solve your problems. Okay, so that is what we need to know about our camera. And that actually ran just a little bit long, so that I think is where I'm going to close out this portion of the lecture, and go ahead and make sure you watch the third and final video for this week to talk about your assignment. Okay, so in the next video, we're gonna talk about your assignment. I'll also post a reading, and we will talk about quizzes. We don't have one yet, but we will coming up soon.